So, Lobrit from Igaunia, yeah, that's my Latvian, that's all. I can say also Baldies, but maybe the pronunciation is not that good. Yes, as said, my name is Kaia Eichler, I come from Estonia. I will have a slide about that. But before we start, I would like to see who are you here today? Because I assume most of you work with HVAC design, yeah? Heating, ventilation, air conditioning? Yes. Is it all of you? Some are working with energy efficiency in buildings? No? Electrical engineering, something? No? So HVAC, everyone? Okay, good. So yes, I will talk about sustainable building design in practice. It's a very big, wide topic, and I try to scale it down. Let's see. And I will talk slowly. Yes, and I will talk in English. Sorry, that's. So as said, I come from Tallinn, and then, well, almost 10 years ago, I studied 1 year in Barcelona. In Tallinn, I have a Master of Science degree for environmental engineering, and specializing in HVAC design. Though during those 5 to 6 years, I realized that design is not really what I would like to work with, so it's more energy. And therefore, after 1 year in Barcelona, I went back to Tallinn, and then I went to Gothenburg, Göteborg, as we say. There I wrote my master's thesis in thermal energy storage in a company. I did like an internship, and then I stayed. I learned Swedish, so now I work as a sustainability or a sustainable building consultant since 7 years. 5 years I have worked with simulations. We could say a lot of simulations with mostly IDA also, as Alice will talk about later. A lot of daylight, indoor climate, energy, and so on. Yes, and there was the slide for that. And right now, then, 5 years I worked in a company called Bengt Dahlgren. It's an HVAC design company, and today, since 2 years, I work in OF. And here, a bit of a presentation. What's that? So this is a Swedish O, as you see there. So it's a A with a, you pronounce it O, so OF. It's one of the biggest consultancy companies in Sweden. The sales are 11 billion Swedish krona. We are 9,000 people worldwide, and we have 100 offices. I don't actually know if we have one in Latvia. Does anyone know? Do you recognize the name of this company? No? Because in Tallinn there is one, and actually it's in the energy field, HVAC and energy. So we are established more in more than in 30 countries, and assignments are carried out in over 100 countries. You can see it on the world map. And our new motto is making future. The organization, just for you to understand like the possibilities in the company, that we are divided into 4 divisions, and we work with industry, so that's like mechanical engineering, for example, Volvo. Everybody knows Volvo, right? It comes from Gothenburg, actually. Did you know that? Yeah? So that's mechanical engineering. Then we have infrastructure, where I work. So it's all buildings, roads, bridges, and so on. Then we also have international, so that's basically everything, let's say, outside Sweden, more like bigger projects for energy production, you may say so, or transfer, energy plants. And then technology, that is IT engineers. Why is that relevant? Is because in this company, there are many possibilities to work with other disciplines that are not only civil engineering. So, for example, from the industry side, the engineers working for Volvo, as they do like a lot of simulations there for CFD, then we can have a collaboration with them and learn more and to how to apply that on buildings, for example. Or with IT technology, that how they do also like product design and so on. So it's a lot of possibilities to work together and to learn from each other. And that's a difference from our, let's say, competitors then, because they mostly have civil engineering. Well, the sound is working good. No, it's good. This is buildings business area in Region West in Sweden. What kind of disciplines we have? This is our office building in Gothenburg. Swedish there also. Leading consultants in ventilation in surgery rooms. Does any of you work with that? As you noticed, there are a lot of ventilation channels in ducting in the walls. And here is this almost the last one, and with no music. So this is like all the disciplines we have in the office where I work. Of course, we work with all the other offices also mostly in Sweden, because the building design is very local market, so it's not super international. So I work mostly in Gothenburg or in the Västra Götaland in the region. What you notice maybe here, what is missing is the architect. Currently, we do have architects also in Stockholm. Let's see in the future, we might have them also in Gothenburg. That means that we can do the whole building design from one company. And that's something we're working on already. Some projects that we have that is except the architect in the region then. And where I work, so now when you come to Gothenburg, you will recognize this building. You will know that is where I'm working. So today I'm working as a section manager or department manager for sustainable building. We are about 10 people working only with what I'm going to show you today. Then also we have another colleagues in energy management that work with existing buildings. And so we have a lot of collaboration with them. And also we have automation group that has energy focus and so on, and then the classical design principles, as I said. In sustainable building, we work almost only or mostly with new buildings. So also my presentation is about new buildings. A lot of office buildings, hospitals, or commercial buildings. Some residential buildings also, because as you may have heard, in Sweden there is a big construction boom right now. We're building a lot. And also the reason is that there's a lack of residential buildings. So people have nowhere to live, basically. So that means there's a lot of jobs for us. So I'm going to show you some practical examples about sustainable building, what I mean with that. But first, what is sustainable building? So everybody has heard of sustainability many times. Do you know the three different aspects we refer to when we talk about sustainability? Anyone? So sustainability is achieved if you have achieved these three aspects. It's economic, ecological, and social. Then it's the only way that we can say that we have achieved sustainability. So what is sustainable building? Then we talk about energy, environment, and certification. With certification, I will come back to that. I mean, different kind of environmental labeling systems. It's like a quality method in projects. Yes. And now, just one moment. I need to use this because I had a cold for 1 month. But you can think why you're working with this. So why sustainable building? Why do I have a job, let's say? Why there is a market or demand? Well, since I work in Sweden, and my Latvian is not so good, well, of course there's in English also, but I haven't read the Latvian energy performance minimum requirements. But I can show you the ones in Sweden, and then you can reflect or even tell me what's the difference, because for the energy performance in buildings. But why we work with this in Sweden and why it's very, very relevant, a lot of job. It's because in 13 years, the minimum requirements has been decreased by 60%. That's basically the reason. Now I'm referring a lot to energy performance here because we're talking about the design today. So not so much environmental performance. This why we have decreased them 60% is because it comes also for the EU directive. EU directive comes from the Global Sustainability Goals. So this is the progress has gone very, very fast. So it means that we need to work in a different way in projects to achieve these requirements. And it's also why it's relevant is because let's say when I started working with this question, it was more like a choice in projects, like, oh, we want to have a green profile, so we do like super energy efficient building. But today, and in the coming years, it's a requirement by legislation, so you have to work with that. So if anyone wants to move to Sweden, so there will be a lot of jobs in this field. And of course in Latvia also. And here, what are we talking about then? I have tried to illustrate it here. It is rather complicated because it's how we calculate, but just for you to get an idea of what numbers we are talking about. Because let's say in the past half year, 1 year, we have got 2 new different legislation versions. So they have changed everything. So in every project, the first question is not what building you're building, it's more like which legislation is applied to this project. Because then you know how to calculate it, let's say, or to work with the question. What is BBR? It is Boverkets byggregler. So that means that's the minimum requirements for how you build buildings. And their chapter 9 is for energy. These numbers here are in kilowatt hour per square meter year. I haven't translated that. Square meter year, how you say, heated floor area, as you know. Yeah, it's the same, more than 10 degrees. And here is the version of the different legislations and when they came out. So basically, 2008, you have achieved the requirements if you have maximum 100 kilowatt hour per square meter year, but it's not total energy use. We are talking about the building's energy use, and this is where it becomes complicated. So I try to make it short because Sweden is the only country that does this division. So what I'm referring to is that the energy used for heating, so for the heat transmission loss that you have to with the radiators, for example, the energy used for cooling, the energy used for the fans, for HVAC units. That is what you have to, if you sum that up, and for hot water, domestic hot water also, then it has to be maximum 100. But in a building, you have more energy than that. You have also the lighting, you have the computers you use, and so on. So the division is made basically that's what comes from the building, and that's what comes from the tenants. Are you with me? The difference there? So basically, the total energy use would be here, maybe say 125, 130. Of course, that's the rest is where it's not really calculated because you assume that you have some how you say experience from previous projects. So assume that, and you hope that it will work. What has also happened here, 2017 with this, is that we have also, because in Sweden they keep it still a bit simple with this kilowatt hour square meter a year. But now, since the EU directive has also enforced that we need to have primary energy factors, as we have in Estonia, for example. So now it will be a bit different story. But still here in my comparison, I'm using this number, because that's what we talk about when we talk about having energy efficiency, so like decreasing the energy use in buildings. You with me still? Yeah? And you remember they said 13 years. Well, we are coming to that. This one, I will also mention this later on, but Miljöprogram is the environmental labeling system used in Sweden. Quite simple system. But in order to have the highest level there, which is gold, you have to have 65% from the legislation, the energy use. So there you see that where it's needed to work even more with this sustainable building. And there is also a new version. So it's very confusing right now in the Swedish market because we have so many new versions at the same time with different projects. But yeah, that's why you need consultants to know about them. And here, as you see that, well, 2008, no problem. You can have no problem to build a building with 65. But now, when you come to 2017, it's very low. And then, in 2021, which is the nearly zero energy performance requirements you've heard about. No. This will be enforced in Sweden in 2021. Also a year when Gothenburg is celebrating 400 years, so if you want to come there visiting, there will be a lot of things happening. But the point here is that we are going to have even lower requirements. So this is probably not the... I think that because 2008 we talk about having lowered from the legislation to have green profile. But in 2021 I think that everybody will work with this number. So there won't be any more that you have to achieve such low performance. But we don't know that yet, because that hasn't been enforced, because we're not there yet. This word here means the client's requirements, so the property owner's requirements, because in Sweden most of the biggest property owners have their own requirements for sustainable building, which is usually the same as the environmental labeling systems requirements, or even tougher. So this was about the background. Any questions about this? No? So 60% lower energy use. Can you hear me? Because I think I'm doing this now. Yeah. So what does this mean in practice? When I was preparing this presentation, I had a lot of pictures. And I was thinking, okay, but let's like really talk in practice. So I chose one project that I'm working on right now. Been working on since 2 years. And just as an example, what we do there. It's quite a special project because it's not every project, because it's a lot of innovation there, the main focus. But still would be a good example what we can do. Yes, this project is called Johanneberg Science Park 2. It's this one, the red building here. We have why it's number 2, because here we have number 1. Johanneberg Science Park 1. Johanneberg is an area in Gothenburg at the Chalmers University campus area. Maybe someone has been there, Chalmers? I've heard of it. No? Yeah, you've been there. A lot of scholarships. A lot of Estonian students actually go there to their masters. It's a very good technical university. And the property owner is Akademiska Hus, which means academic building in Swedish. So it's a property owner that mainly builds university buildings or laboratory buildings for yeah, you understand. So this one is an office building. So quite simple operations in there. This is the architect, Tengbom, Swedish architects, and it will be Miljögrados. What else about it? So it's a new office building, 11,000 square meters. It is already under construction. We are coming on, I think the basement is already done. But at the same time, we are still in the design process. And should be, you can see it ready 2019. As said, Akademiska Hus is the owner, and also the, this is where they translate, maintenance. So they will do the maintenance, and therefore they're very, very interested in that we have a very low energy performance, because they will pay for it. Well, okay, they have tenants also, but they will maintain the building. So all the systems have to work perfect, because they don't want to have problems that cost a lot later on when the building is done. It is also an innovation arena for cooperation or collaboration between academy, trade and industry, because it's in this campus area. So the idea there is that you invite people there, and you have a lot of different companies. So it wouldn't be that all OF, my company, would sit there. The idea is that you have different companies that will work together. It might be also competitors, but it's not really the attitude in Sweden. We are all colleagues in the industry. So we work together, and that also means that we have a lot of new innovation and new ideas. We, OF, are innovation partners with Akademiska Hus. What does that mean? That means that there is some innovation projects within this project, or parallel with this project. Our consultants, then we are partners coming up with new ideas together with the property owner, and also at the same time, as we learn so much from this experience with working a lot of different disciplines in a different way, then also we, finance-wise, we get paid for half the time. But since it's really good for everyone, so we want to do that. Another interesting part here that I think will be a bit difficult for me to explain, because I didn't know the really English word, is, that word is in English, partnering, but the word for how you do the construction entreprenadform. Can do that. So it's like, I guess that in Estonia, we normally have the main contractor is like a total contractor that hires all the people under them, you know. So for example, Akademiska Hus hires a contractor that builds the building, and that contractor will hire all the consultants, all the under contractors and so on. Yeah, you following me? So it's, and that's what you call total entrepreneur in Sweden. And that's quite like old school style. It's like that Skanska, for example. You know Skanska? Yeah? They left Estonia. I don't know if they left Latvia also. They were surprised that the market is not the same in Baltic states. But anyways, in this project we don't have that. We have partnering. What means partnering? It means that that very early in the design stage, the contractor is already there. So normally, me as a consultant, I start very early in this design. We design everything, we do it, everything is ready, and then we hire the contractor, and they build the house. But now it's like when I'm doing the design, the contractor is already there saying like, no, do this, do that, or vice versa. This is how we have planned everything, so, and that's the idea behind, so we together find the best solution. And this is a very good way to work together, but it's only if it works well. Because now most of the projects are called that we have partnering type of construction form or contract, but it doesn't always work the best way. But not in this project. Here we have the very good main contractor, very good property owner, and it means that you have to also, everybody has to think a bit different, like really collaborate and find best solutions. Not think about, oh, what I get from this and how much I earn. It's more like, okay, how we do this the best way. Yeah? Oh, so I can take a break and show you some more videos. We were playing here just to visualize, because we are no architects, but to show the house. Okay, that was it. Some furniture. It's all about visualization right now. You have to show pictures. For example, when you work with architects, you have to really show them. The text doesn't work. No one reads text anymore. So here we just try to show it, because we talk with our other colleagues in industry and in technology about this project and how could we do it in different ways. At OF, because we are the innovation partner, and they don't work with buildings, they don't know what I'm talking about. So you have to also show them, this is this is what we talk about. We have this ducts here. Can you do something different here for the control system, and so on. Yes, here. Now I just used the Swedish slide for this. The goal here is 35 kilowatt hours per square meter a year. For this building. That has been a challenge, because since we started 2014, I started with it 2016 with this project, is that of course the building has changed completely, so you can't really maybe achieve the same goal you have set at the beginning, but at the same time you set the goal high in order to work for it. I chose to have this picture because you will relate better to this, because otherwise I didn't have so many numbers. But here you can see the average U value for the building should be lower than 0.3 watt per square meter Kelvin. So that's super low. Actually, we haven't really achieved that, because of that we have 40% windows, for example. And how you form the building is very important to work with that early stage with the architect. So window area from facade area above ground, 40%. That's the requirement, and we are exactly 40%. Of course, the architect wants to have 60% in the beginning, but that won't work with this U value. So this is the main key values or principles to work with the early stage in the project. Well, of course, this is requirements for the infiltration, air tightness, 0.3. That's quite normal right now in Sweden to achieve that. So it's nothing super special, but still you have to think how you build the facade, for example, that it wouldn't be, that you don't build inside that it will leak a lot. So there we have, for example, here I've written it's a U value for curtain wall, because I have chosen a curtain wall system with Swegon profiles, if you know that. That means that we already have a lot of thermal bridges in the facade. So that's a big bit of a challenge for me then to explain them that, well, if you choose this, then I need more insulation on the roof, for example. So it's a give and take discussion. Like because of course it's the main goal, even if we talk about really low energy performance requirements, the main goal is still that you will rent out the building. So if no one likes the building, even if it's super energy efficient, the client has no business. So you still have to understand to whom you're building the building. So in this case, since it's office building, you can't go lower than 40% in the window area, because no one will want to work in there because it's dark. For example, very rough comments on this, but it's very important that when you work with sustainability, you still understand what is the business about. So business is you build it for someone, the house, and that someone has to want to use the building also. For example, in hospitals, I think that normally, or sometimes we forget that we're building a hospital for actually the hospital operations. We are not building an amazing building in the middle of the forest that everybody will go to visit 50 years. We are building a scale to fulfill a function. So when the architect comes with very amazing facades that are super expensive, then we really lose the idea with the goal with that objective with the building. Have I used my time? No, I have 30 minutes. Yeah. Then also
45 minutes with the questions.
Oh, okay. So say 20, and I will use 30. Yes. So also here you see this is cooling power. So 25 watt per square meter. That's not really either what we have achieved, because these are like the main requirements from the property owner for all their buildings. And then we do the best to achieve them. But the point here is to see that there are many, but some of the requirements are, they are not working really together. So if you fulfill the one, don't fulfill the other one. So you always have to work with optimizing the building. So it's give and take. Then daylight calculations, thermal bridges I mentioned. Here we come to the most interesting part for you guys. This is the heat exchanger in the HVAC unit. So it's has to be higher than 85% if it's rotating. That's also quite normal requirements already. But it depends also how you then design the whole system. Because when we come to a specific fan power, 1.3, it's quite hard to achieve here. And that we haven't done for other reasons also. But then all the time when we don't really achieve some requirements, then we have to motivate them. And it's all documented, and it was all signed by the property owner's technical group. So you can't really take your own decisions we don't care, it didn't work. It's more okay, did you really do everything you could to achieve that? Yes, we did, but since we have done these changes, then we couldn't have exactly that number. But it will be good anyways. But still, to describe how the process works with the requirements. I have more pictures on that building. Here I didn't mention this, but I will come back to that if we have time. It's for solar shading. Any questions so far on some numbers here?
Yeah, I have a question. The value 0.3, it's total for windows and the facade.
Sorry?
The U value 0.3.
Yes.
It's total for the windows and the facade.
Yes.
So what is the U value for the windows? Do you know?
Good question. Yes, I know, because I work a lot with facades, a lot. So the U value for this project, including the frame, is 0.8. That means when we are building curtain wall, stucco, profile, that the glazing is 0.5. And that's super low. If you want to go lower than that, you have to change the argon to a krypton, and that is not environmentally friendly.
Fake glazing?
Yes.
Yeah. And the walls, thickness and the U value? Do you have a slide line?
Well, no, good that you, because I don't have more numbers, but I have them in my head, so I can, anyway. The requirement on the external walls is 0.15, including thermal bridges. In this project, it's lower than that, because we have 40% area here. Because we, instead of having, this is a bit older picture because I have more pictures then. Instead of having the fan room on the roof, which is normally considered quite good basic energy efficiency measure, but instead the property owner needs to have more floor space to rent out, so you have put all the fans in this basement. That means that we have more glazing area, so you have to compensate all of it. But in general, I would say that the building has a quite good form, because it's not too narrow, it's not too deep. It is a bit deep, because then it means also we need to have windows, or in this ribbon style windows, because to have the daylight long far inside the building. And then also this is something that I will talk more about, because this is not energy efficiency, but we have solved it. It's of course, as we say in Sweden, balansgång, like the balance, to find the balance with working together with all other consultants and the architect, is to understand also their design, what's like the idea with that. So I can't go like say, no, take it away, because this is facing south, this is south facade. So you basically just build a glass wall and you let all the heat inside. So you have to do something about the heat. So you're like basically why you put, like this is all wrong from the beginning. But the idea there is, since it is collaboration between academy and trade and industry with different companies, then it also that it would be open and welcoming building. So then you solve it with technical solutions. Very shortly, what we've done very early was that we've done quite basic LCA. LCA is a life cycle analysis, cradle to grave, of framework material. That we have just quite basically looked in wood, concrete. That wood framework has 35% less greenhouse gas emissions. That means that now this building of 7 floors is built in wood. Everybody's like, what? In wood? Are you kidding me? Office building? Why complicate your life? Well, because we are working with sustainable building. And that has also made, like, let's say, new challenges for the structural engineer, for the acoustics engineer. And now we have also an innovation area or innovation project in this project for acoustics, because it's much harder to achieve the acoustics requirements that we also have from the environmental labeling system that is higher than the legislation, to how to achieve them between the floors and so on. Because the wood material, it's natural material, so it moves and it's alive, let's say. So, but at the same time, it means that we learn new things and we find new technologies, which is quite amazing. But that's not really my area, acoustics. But I work as to get like that we fulfill all the requirements. This is quite a basic study for the solar radiation. So kilowatt hour per square meter outside surface, let's say, per year. So just from the 3D model, take a picture and you see that, okay, where should they put the solar cells? Here, of course, is the best, but then on the roof, it's quite good also. So we have solar cells on the roof, which is very, it's not really innovation to have solar cells on the roof. Most of the projects have that. But we did also look into the facade to have them integrated, but that's not really cost effective because it doesn't give that much energy as it costs, the investment. And then, of course, you always work with the cost, of course. We don't have endless amount of money. And this also, in this type of, the construction contract that we have, that is, so everybody is thinking about the cost. So it's like you're open about the information with the property owner with the constructor. Like, okay, but if we do this, can we minimize the cost? And it's very interesting to work like that because normally, I would say in design process, early stages, we don't talk so much about the cost of actual systems that we build in. Here we have looked about, just an example about the shadows over here, and here we see the south facade is not any shadow at all from the other building. Well, here those buildings were not in the model now. Yeah, that means that we will have a lot of daylight, but at the same time it will be very hot. And what we do about that? That it wouldn't be hot. Here we didn't open any windows. The first picture was 36 degrees. So this is a study. Well, normally it's also like this, that you work with the question so you know the result. So you say to the architect or to the client, like, we will have problems here. Then they're like, oh, yeah, are you sure? They're like, okay, we can do a study about it. And to say, just to prove what we have just said. So you do a study. And here, this is also like, because I mentioned my colleagues in industry and working with Volvo and vehicles, they do like super amazing detailed studies for CFD. This is very, very basic, but still quite hard for us to do, because that's not really what we work with. I mean, we work with simulations of buildings, but we don't work with that specific topic about how the air moves and what is it depends on and why. So let me move back maybe. So the result here was that we will have 36 degrees here. The requirement is 25 degrees inside, maximum, for the cooling. The challenge here is that it's through 6 floors, the atrium. This is the south facade, this is the north facade. Another thing also that in the beginning we had an atrium through the whole building, but no glass on the roof, glass only here. And then we checked that, it will be very hot, so what do you do about it? Yeah, as you see in this picture. So these are the different floors, because people go here, they cross from one side to another. Then the project advances. We have new principles. We need to have more tenants, maybe. So we cut in half the atrium. It doesn't anymore go from south to north. Now it's flipped because this picture I couldn't print it. So anyway, so it's from south to north. We couldn't, because if it goes south to north, where the heat comes in and then it goes out. No problem. And then we just checked that it wouldn't be too high velocity on the air with our basic simulations. And they cut it in half because here we will have more office space. That means that all the heat that comes from exactly the same glazing area will be now in a much smaller space. We were like, okay, have you really thought this through? But we understand the reasons why we do that. So then we've done similar calculation in another program, because we needed to do it in another program. And this was the result that we will open here some, the facade or like windows or natural ventilation hatches here and then up on the roof. So just to ventilate it, because we can't put like cooling beams there, because that will not go together with our energy performance requirements. And this also sort of, it's a combination of simulation to see that how we think it works, but it's also a combination of experience, because with natural ventilation, I don't know how many of you work with that, because today it's not so common, and it's also, I think that there are not so many people who really know how it works, including me, but I have worked a lot with the atriums. So it's a experience that you think that this will work, and then you try to like prove it with the simulation. But not only that, here we check the temperature and then the velocity, and we saw that okay, we need to open it there also, because here it's like really. We didn't want that if someone goes here that you have papers and they go fly away. Well, I don't think that would happen, but still, to double check that. And But not only that, because you can't just open windows and you think everything will work. That's something I say to the architect now. But because they don't like it, is if you open the windows, you have more frame area and the looks, the aesthetics will be different. But here we have good architects and they understand that we need to do that. But it's not only about opening windows, it's a combination of many other aspects. So here we have the solar shading solutions. In this project, we have microshade in the atrium facade. It's 140 square meters atrium. Microshade, it's a micro lamella developed in Denmark. Someone has maybe heard of it? No? It's a very small company that with the university that now is a company that they have developed this kind of solar shading. It's quite complicated to calculate it, so that's why it's complicated to actually to enforce or apply in projects. But since we think that we know everything, so then we say, yeah, this will work. This is the best solution. Why we chose that? Because it's a passive solution. Because it doesn't go up and down. It's in the atrium, and in the atrium you actually want to have daylight. So this one is also something that you can still see through, compared to, for example, screen print, or to having something that is fixed on the facade that wasn't an option for this project. This is the G value for that is very low. Yeah. But I will try, time-wise, I will try to go faster, so maybe if you have questions we can take them later on, because this is something that let's say, my personal area is to work with solar shading and facades above or among other simulation areas. Then we have zip screen on the office floors. Then I've done an illustration here that, of course, for the architect they will understand that there will be this outside on the facade. We talk about entry glazing. And then we were supposed to have electrochroma, which is glazing that you put like electrical, impulse in it, so it goes dark, so it works as like solar shading. If you think about the cost of this, of all of them, these two are quite expensive if you compare them only with glazing, but if you compare them with the glazing and the external ones, then it will be approximately the same. As you also see here, that all of them have approximately the same G value also. So it's very hard to come so low G value without having external automatic shading. So this is also something that we have worked really a lot with in this project, and this is also something that all these labeling systems do, that we have to have external solar shading. It's the same, you skip that. We have done daylight analysis, so this is, there will be an open office there, open landscape to call it, and so here we just check the whole floor without any furniture. It's quite simple in this project because you have the same ribbon, window ribbon, so it's the same one office that is the design principle or the dimensions, the whole building. And then here we show, yes, here you can't really have offices that people work in because it's too dark, because you don't then you don't fulfill the requirements. As you see here, you have to daylight factor 1.2% to have gold on the. Yeah. I will not go more into detail time-wise on this, but we work with daylight. That's the point. A lot of different kind of simulation, a lot of different kind of simulation programs to analyze the building. For example, this one is facade optimization. So as I mentioned, like this is a regular office, 2.4 meters, 3.6 meters, like single person office, cellkontor we call it in Sweden. And then you put here like, okay, I have to achieve a daylight on 800 millimeters from the floor level. And I have to achieve that I don't have too much solar heat with that kind of glazing. And then it works, then you push play and it calculates you, this is how it will look. So this is something we're working on to work more with architects early stages. Instead of doing like 100 different simulations back and forth, because daylight and solar heat calculation is not the same. Well, now it's the same program, because at least we talk about it later, but it's not really the same methodology or the same parameters. So you really need to remodel the model and then calculate it. So here it does this in this program, very fast. But it's not as easy as it looks here. It has to gain some time to figure out. Illustration of how we have in the project been talking about about U values. Just like, a lot of brainstorming, sitting down, okay, now we have to do this with all the project group. And then we decide, okay, here we will have microshade, there we have zip screen, then we will have more, here you see the glazing 0.5, and then it's 0.7 for the total. So how we achieve it. And this is something, it's a meeting that I'm leading with the project group because they would really understand what we're doing. It's not only sending an email or giving them a document, like this is the number and do it. It's like really that they will understand why they have to do it. So that's a good, it's also a challenge, but it's also like what's fun about the work. Time-wise, so conclusion on this project. We have variable air volume. Everybody was wondering that, for sure. I'm talking about daylight, but you were like, no, what's the HVAC system? So variable air volume with climate simulations we have done, indoor climate, I mean. Natural ventilation in atrium, I call it for. Then we have lighting with low installed power. Electrical engineering is quite simple when it comes to the sustainable building. It's more like when they measure the stuff that they do it very complicated. Lighting with daylight control, of course, because we have a lot of windows, so we should definitely have that control. Framework of wood to reduce CO2 that I mentioned before. Sugar curtain wall facade. Microshade in here in the atrium. Zip screens on all these floors here. Electrochroma, well, that's not anymore, but we wanted to try different facades here. But due to cost and so on, so we don't have it anymore. Window design for daylight, because it's the ribbon and also the height. In last minute, we actually decreased the window size due to we didn't have problems to fulfill the U values. So the architect was not so happy, but they got something else, like they want to have green roof. We will see if that will happen, but yeah. So it's give and take. Yeah, as I said. Solar cells on the roof with batteries. Very shortly, yes, we will have, Tesla. We will not have Tesla batteries, but we will have batteries in this building for the demand and production, to have them at the simultaneous, so it's another innovation project here. And that hasn't been really done so much in buildings, so we will see how it works. Then also we have DC, what's that, direct current? So not AC, DC from the solar cells, because solar cells have DC, and we're not having the exchanger in between that you have losses. Then we want to have DC for example, for the HVAC, for the fan. And then we have to call everyone, okay, do you have a fan that you will sign the warranty, that it will work. So it's it's a lot of to explain what we are trying to do here, that you normally don't do the same way. So it's another innovation project here. But otherwise, in this campus here, they have their own district heating, the local plant, and then we have district cooling, because I thought that you would want to know this, how we otherwise have the building. Because we didn't have enough space to have geothermal boreholes, for example. But we had that option also from the beginning. This other building has that. It has, say, 200 meters down boreholes, heat pumps. And then, also very shortly, PCM energy stores, another innovation project that I'm very happy for, because this is my master's thesis. PCM is phase change materials, so salts or paraffins, that you can store the thermal energy in, and then you can reduce, in this case, cooling power when you have the peaks. We can talk more about that later, so we'll see. So as said, we have high energy performance requirements, high ambitions for sustainability, and we have miljöbyggnad good. Yes, I was just thinking, I will try to, because I have 5 minutes for me and 10 questions. Oh. Because, so very shortly about environmental labeling systems that I have mentioned many times, and Petra mentioned in the beginning, because you have a book about also where you can read more, Simply Green. So I have talked about miljöbyggnad. It has 15 different parameters, or parameters that you have to fulfill. So it's very simple system compared to LEED and compared to BREEAM. Have you heard of them? Worked with them? Different labeling systems. This is from England. This is from the United States. This is a European initiative to only for energy use. Then we have Living Building Challenge. That's the Canadian version. But that's we don't use so much. There's a new one also that's called WELL, that is only for the indoor climate that you work together with LEED. So it's like more like the soft parameters, like how do you feel in the building. But it's very, like, since we work so much with those labeling systems, so it's already next level that you are thinking of even broader perspective. So there's also City Lab, that is for the whole city area, or like so many buildings together, like how do you design them? And these are then, how you say, maintained or managed by Sweden Green Building Council. There's also Passive House, that is from Germany. There's Sequel. There are a lot of different systems. But back to miljöbyggnad. So this is the one that is most popular in Sweden. It's a Swedish system. And very, very shortly about it. It's divided in 3 levels. Gold is bronze is PBR, which is the legislation. So if you have miljöbyggnad that achieves bronze, you basically have the quality check that you fulfill all the legislation requirements. So basically, that's no high ambition. Why do you work with the system then? But you want to, in some projects, you still want to do the quality check, because there's a a third-party control of all the paperwork. So that's what I do. Also, like to gather all this paperwork for all the different calculations or acoustics that we have fulfilled the requirements, and send them in. They will be controlled by a third party, and then you get the certification. Because you don't have this for the legislation, no one will check that you actually done the job. Because now now we have the requirement of verification of the energy performance. But let's say in my experience, no one has asked me that. Did you really actually fulfill them, like from the government side? Then we have silver, that is a bit better than bronze, and then we have gold, that is requires more effort. And then also in the end, you ask the tenants, do you like the indoor climate? Do you like the acoustics? And if they don't like it, then you don't get gold. So it's a bit why you work with that, the whole project. It's divided in miljöbyggnad is divided in 3 different areas. So it's energy, climate, and materials. Materials is like how you build the building, which they don't have chemicals that are not good for the environment. So this is very shortly, because I want to come to this, because everybody is definitely wondering how we do this. Because I show you a lot of practical examples of how we work with sustainable building, but how you actually make sure that you fulfill the requirements. How? Yes, you hire me. No. Well, yes. So it's this is what I call for energy environmental coordination. A bit lost in translation this word, because I don't really like that. This is not the coordination really, because you're still like a project manager for energy environment. And but at the same time you collaborate or coordinate with the people. So in the beginning, I'm sorry, this I didn't translate, but I think you get the point here. This is the building process. So it's early stage study, where will you build and what will you build. Then you do a very, okay, the house will have, or the building will have so many square meters and it will look so much, very like, how I say, the documents will be quite rough, but still you know approximately how much it costs. Then mostly here comes the HVAC design and the electrical design, that you do the design documents. Then you build it to production. Then you check that you built as you were supposed to and everything works. And then you have the maintenance stage here. This picture illustrates that in order to achieve with a sustainable building, let's say, so it's energy, environment, and the certification, you need to work from early stage until the end. The difference here also is that with other consultants that we actually are here still 2 years after the building is done to verify everything. So we really work like from the beginning to the end. I mentioned this project, Johanneberg Science Park 2. I worked with that 2 years. I'm probably going to work with 2 years more with that project. Then there's another project I worked from 2011 since I started working. And so it's a really long process, and that other project I will work 2 more years also. So it's also some means that you have to have good quality system, because if you need to exchange the people there, that you still have the information, of course, but that everybody has that. So basically you need a project manager for that question. Then we have a team that we do all these simulations, analysis. But you need to have someone that says, this is the requirement. So that's what I do in the early stage. I say, this is the requirement, this is what we have to fulfill. Then later I will check, can we fulfill them? And then to verify them. So it's a quite challenging role in projects, because even in Sweden it's not super jättebra everything, because a lot of projects still don't really understand the need of this role. Because we need to work in a different way, we need to collaborate with everyone, all the disciplines are involved in this work. And they need to want to work with that. So that also requires a new project organization. And so here we have the project manager, the property owner, the client, let's say. Normally the organization is that then you have the architect, the design engineers, structural, and the contractor, the one building the building. In order to really actually do something and be proactive in the projects with these requirements, you need to have the coordinator that is like a sort of an assistant project manager. So it's only for the energy and environment questions, but it's not here like all the other design engineers. The reason is that because here I do the requirements. So it's like I can't be, if I'm here I'm just doing the calculation. I'm like saying, yeah, you build, you throw a house like this, I calculate and say, you don't fill it. Point. You don't do more. But here you say, okay, but this is the requirements, this is how we have to change it. You have to change the building. It's not only that, oh, you don't fulfill it. How you fulfill it. Any questions on that? Yes, I think I'm done now. So just final words. The most important about my presentation is to understand that sustainable building is that we need to work together with all the disciplines to really be able to achieve the requirements. That is also, it's a legislation. It's not a choice anymore. And you need to work in a different way. So you need to be more open-minded. Thank you.